Hi, today we're going to take a look at the triangle proportionality theorem. Triangle proportionality theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Let's take a look at an example. Here we have a triangle, and we're going to draw a line parallel to the base that intersects the other two sides. And let me go ahead and label some points. What the triangle proportionality theorem allows us to do is set up some proportions in order to find the lengths of missing sides. So we could set up a proportion where AD, which is the larger piece of this side of the triangle, over DB, which is a smaller piece, would be proportional to the other two sides, AE over EC. Now we could use the properties of proportions to rewrite that. We could do the top over the top, so AD over AE would be equal to DB over EC. That's just another way to write it. The proportion is exactly the same. There are some other proportions that we could use. We could do the top piece here, AD, over the whole side of the bigger triangle, which is AB. And that would be equal to the top piece, AE, over the whole side of the bigger triangle, which is AC. And again, you could rewrite that different ways as well, depending on your the way you want to write your proportion. Another way that we could do this is we could do the small piece on the bottom here, DB, over the whole side, AB, and then that would be equal to the small piece over here, EC, over the whole side, AC. So those are just a few of the different options that you have. One special case, however, is if you are looking for the bases of the two similar triangles, ADE and ABC. If you have DE over BC, you would have to use one of the sides of the larger triangle. So let's say we have AE, and that would have to be over the whole side of the larger triangle. Since DE and BC are whole sides of the triangles, and AE is a whole side of a triangle, we would have to use AC. This is a special case right here. We're going to look at an example like that in a minute. So let's do a few here using algebra. Right, for this one, we can use the larger piece here over the smaller piece here, and the smaller piece here over the larger piece here. So that proportion would be 6 over x equals 3 over 4. And we can cross multiply. 3x would equal 24. And x would equal 8. Let's take a look at another one. For this one, we need to find out what this smaller piece is here, or we can set up a harder algebra problem. I like to do the easier way. So if I know this whole side is 20, I can subtract the 8 to figure out that this piece would be 12. And then I can set up my proportion from there. 8 over 12 equals 6 over x. And I can cross multiply. 8x would equal 72. And 72 divided by 8 is 9. If you did it the other way, you would do 8 over 20, which is the whole side, and you would have to do 6 over 6 plus x, and then you would cross multiply. So x times the quantity, 6 plus x, would equal 120. And then 48 plus 8x would equal 120. And if you subtract 48, you would end up with the same answer. Now let's take a look at one where you have the bases. So for this example, we have the 9 and the x that are the whole sides of the larger of the two triangles. So we can't do 6 over 4 equals 9 over x. We can't do that. We have to do 6 over this whole side, which is 10, and that would equal 9 over x. And then we can cross multiply and get 6x equals 90, and 90 divided by 6 would be 15. So that's the special case I was talking about, where if you have the two bases of the triangles, you have to use the whole side of the smaller triangle and the whole side of the larger triangle. Right. When we learn about the triangle proportionality theorem, we can also look at this theorem that involves parallel lines. If three parallel lines intersect two transversals, then they divide those transversals proportionally. So this is very similar to what we were just doing. We can set up a proportion. The pieces on this transversal are proportional to the pieces on this transversal. So we can do x over 20 equals 9 over 15. And then when we cross multiply, we would get 15x equals 180, and x would equal 12. Now, by using our properties of proportions, you may notice that we could also do x over 9 equals 20 over 15. We just couldn't go across, so we couldn't do x over 15 equals 9 over 20. And we have one last theorem for today. The triangle angle bisector theorem says if a ray, that would be this ray right here, bisects an angle of a triangle, cutting that angle in half, then it divides the opposite side, this is our opposite side here, into segments proportional to the other two sides. So to set up this proportion, it's dividing the 12 and the x proportional to the 18 and the 24. So that means we can set up 12 over 18 equals x over 24. And then 18x would equal 288. And then if we divide there, we would get x equals 16. Now again, the properties of proportions say that we could rewrite this as 12 over x equals 18 over 24. We just couldn't go across and do 12 over 24 equals x over 18.